Question number 24. Negative feedback in amplifiers. Option A. Improves the signal to noise ratio at input, improves the signal to noise ratio at output, does not affect the signal to noise ratio at output, all of this. Now, whenever negative feedback is applied to, whenever we use this negative feedback concept, just I want to tell one small concept by which you can eliminate one option. See, negative feedback when you apply, this is the input, this is the output signal. Okay, so input signal will be a normal signal, it doesn't have any impact. So but the changes takes place in the output signal. The output signal will get changed. It may have a good behavior or it may have bad behavior. So whatever the impact of negative feedback is applied on the input, that gives the output. So what I want to tell is output gets affected due to this feedback, because this feedback is completely applied on input. So input signal gets changed, then it produces an output. So output gets affected but not the input. So first option, if you see, improves the SNR at input, that is absolutely wrong, because whatever the action takes place, it takes place only at the output but not at the input. So this can, this and this three options are available. From this we need to choose the right choice. Fine. Now let us see what does negative feedback in amplifiers will do. Okay, just try to memorize this point. It's a very simple question. Negative feedback, see, why we will employ negative feedback? So that we will get some advantage, right? So by just normal, by making a small guess, you can make that it reduces the noise. So if it reduces the noise, so if noise is reduced, signal to noise ratio will be improved. So option B is right choice, everybody will tell. So let us see in details of it. So negative feedback reduces the noise by a factor 1 plus A beta, where A is the gain, B is the feedback factor. So this is noise without feedback, just like it's an input signal. So after feedback, what happens is noise will become original noise divided by 1 plus A beta. So original noise, if it is some x, it will get divided by 1 plus A beta. So total noise gets reduced by a factor called 1 plus A beta. So as noise is decreased, SNR, signal to noise ratio, so SNR, signal to noise ratio, if noise is decreased, the overall quantity is increased. So as noise is decreased due to feedback, SNR gets increased at the due to feedback. So the right choice is improves the SNR at the output. This is a very simple question, does not affect this SNR at output, it's wrong. All of this also wrong. So the right choice is option B. Now let us see the extension, so that what negative feedback will do. Many times these questions, what negative feedback will do, is asked in GATE, IES and ISRO exams. So try to remember what are the changes takes place after negative feedback. So let us see it in terms of extension. First one, effects of negative feedback. Negative feedback is also called as degenerative feedback, whereas positive feedback is also called as regenerative feedback, this is regenerative. Negative feedback is called degenerative feedback. Try to remember these two names, because sometimes they'll give like what degenerative feedback will do. Don't confuse, it is nothing but negative feedback. Okay, these are one part of the question. Okay, so now what this will do, just remember, the gain will decrease by a factor x. What is x? I'll explain. Noise and distortion will get reduced by factor x. Sensitivity to external changes will get reduced, like temperature. If temperature is increased, some output is decreasing, so like that changes will not take place. Okay, even if you increase temperature or pressure, all kind of external atmosphere, if it changing, but the output will not change with the help of negative feedback. Okay, it reduces the sensitivity due to external changes. Fine. Then finally, it improves the higher cutoff frequency of the frequency response signal. So it improves the higher cutoff frequency and reduces the lower cutoff frequency. So if higher cutoff frequency is increased and lower cutoff frequency is decreased, see, assume that initially this is the bandwidth, assume this is a lower cutoff frequency, this is a higher cutoff frequency, this is initially without feedback, assume. Now after feedback, what is happening, what I am telling is improves the higher cutoff frequency, means higher cutoff frequency initially here. Now what happens is it will change to some new value, okay, some new value fh, it is increased. Now lower cutoff frequency here, it is decreased. So suppose if it is 2, then it will go to 1, it is decreased, means the bandwidth range has increased. Previously assume that this is 10, now it has become 12. So previously what is the bandwidth? 10 minus 2, 8 is the bandwidth. Now 12 minus 1 is 11 is the bandwidth. So overall bandwidth will increase if higher cutoff frequency is increased and lower cutoff frequency is decreased. So improves the higher cutoff frequency and decrease the lower cutoff frequency. So overall bandwidth is improved by a factor x. X is nothing but, it is not new to you, x is nothing but 1 plus a beta, where a is the open loop gain of the transfer function. Then beta is the feedback fraction or feedback factor. Sometimes in question they'll give loop gain. Loop gain means it doesn't mean beta, it means a beta. A beta is called loop gain. So try to memorize these 4 important points and try to remember their names: regenerative, degenerative, feedback fraction, loop gain. Please try to memorize. Okay, this is about negative feedback concept. Then these are the effects what it does with to the given transfer function. So try to memorize these points. Okay, then a question can be expected from negative feedback and in any competitive exams. Okay, do well. Thank you.